Okay, guys, so this is the second installment of the series simulation, and hope you are doing well. So, before starting off, let us first review the first episode. Just a quick recap. In the last episode, we have defined or actually introduced the idea of simulation. Next, we have seen why simulation is necessary, and I had given you a small model which calculates the total profit based on the selling price, unit variable cost, demand, and fixed cost of the system or the manufacturing facility, and introduce the idea of why simulation will be helpful in this context. Then we discussed every aspect of it, that means the deterministic, non-deterministic part of the equation, that is the unit variable cost, demand, and fixed costs. Those are not deterministic and probabilistic in nature, and we need to answer certain questions, basically multiple questions. So there is not only a single objective but can be multiple objectives to answer. And finally, our model has certain controllable parts or controllable parameters. In this case, it was the selling price, and we discussed how simulation can help us identify the best possible selling price or the best possible decision variable, or you can say controllable variable, in order to answer these three questions. That means the decision variable or the controllable variable that gives the best answers to these three or four questions will be selected as the best solution. So, with the help of simulation. And then we discussed what will happen if we don't use simulation and try to solve this type of problems otherwise. So, we introduced the idea that it will be too much lengthy and difficult procedure if you don't use simulation. And then we introduced the various types of models used in simulations, or actually classified the simulation approach into four distinct categories. The first one was deterministic models, then probabilistic models, then discrete event simulation, and continuous simulation. And finally, we defined random variate and how to use the rand function and the inverse function in Excel in order to determine the random variates. And finally, I introduced all the Excel inverse functions for all, probably most of the distributions that are listed here. And then we went to the Excel sheet to practice these formula just to get an idea. So I requested all of you to practice this in your own facility, in your own capacity, and then come back to the next video. So I hope that everyone has practiced, and if you just don't practice, you will feel some difficulty in today's session, because we will be readily using these functions without much explanation. So make sure that you have seen the previous video before going to the next discussion. So now let us come to today's content. So today we will just implement this particular model. That means this Tp is equal to S minus V into Q and then minus F, this model. I will implement this model in Excel, and for that I have given this problem statement. That means the values of the variables or the distributions that we need to define, I have defined here. So for example, first of all, the selling price is $300 per unit. The variable cost per unit, which is this V, this is S, this is V, this is F, and this is Q. So S is your decision variable or controllable variable. Controllable. Why controllable? Because it is in your hand, or in management's comes under the management decision. So that is controllable. So the variable cost per unit follows a uniform distribution ranging from $100 to $150, right? So you know that any uniform distribution is defined by two parameters, two extreme parameters, that is the lower bound and the upper bound. In this case, the lower bound is 100 and the upper bound is 150, right? Then the fixed cost is following a normal distribution having mean is equal to 15,000 and sigma is equal to 2500, right? So normal distribution is defined by two parameters. One is the mean, another one is the standard deviation. In this case, the mean is $15,000 and the standard deviation is $2,500. And finally, the demand is following a gamma distribution. It also has two parameters, alpha and beta. So in this case, your alpha is 20 and beta is 5. So that is the problem statement. And what is the questions asked? I have already discussed 3 questions can be there, more than 3 also possible, but today's model is a simplistic model and the most simple model you may encounter in simulation exercise. Just to introduce the idea and not to overcomplicate things in the first video itself. So I have taken the simplest model possible. So 3 questions to be answered. One is the average total profit that can be obtained in this price level. What price level? That means if the price level is 300, which we have defined here, at that price level what could be the average total profit? Then what is the variance and standard deviation of total profit at this price level? That means if the price level is 300, what can be the variance and standard deviations of total profit? And what is the third question? Third question is, if the price level is 300, then what is the chance of having a loss? That means a negative profit. Profit less than 0. What is the probability or chance of that? So this is the definition of the entire problem and the questions asked. And if you ask me that from where did I get these numbers, that means 300 or 100 or 150, these are purely imaginary. In any problem, these things will be given to you. So unless these things are given to you, you cannot conduct any simulation exercise. Okay, so let us come to the Excel spreadsheet to implement this problem. So this is my Excel spreadsheet. You can see the problem statement and questions asked. Again, I have copied this from the slides because just to see this side by side, and so that data can be copied here, and then the distribution formula also, so that you can refer to it readily. I will delete these things once the model is implemented here. So to start with, first we will start with, I will just zoom this spreadsheet so that you can possibly see it in a better manner clearly. So from this cell A1 we will start writing replication number. That means the observation numbers that we will write in the first column. What is the second column? Generally it is the decision variable or the controllable variable. In this case, S means what? The selling price, right? Then we will write the uncontrollable variable. In our case, this is V, then Q, then F, and finally we are calculating the TP or the total profit. You know the equation, S minus V into Q minus F, right? So let us now create the first replication. So this is replication number 1. So what is your selling price? In our case, this is 300. See, 300 is written here. What is the variable cost per unit? Variable cost per unit is following a uniform distribution ranging from 100 to 150. And what is the formula for uniform distribution? The first one. So 100 plus 150 minus 100 into rand. Why rand? Rand is the random number between 0 to 1. All these things have been explained to you in the previous video. So again I am saying, if you have not watched the previous video, go back there and complete it. Then you will understand it in a better way. So anyway, I have just implemented this formula. In our case, A is 100 and B is 150, right? So this is your variable cost per unit for replication 1, right? So next is Q, that is the demand. You see the demand is following a gamma distribution 20, 5. So alpha is 20 and beta is 5. So what is the formula of gamma distribution? You can see here, gamma inverse, then probability. Whenever you find this probability in case of simulation, it is nothing but the rand function. Okay, then alpha is 20 and beta is 5. So this is your Q. Now what? Again, I have told this in the last video, that whenever there is a variable which only has integer values, that means it cannot take any non-integer values, then we must convert the output of the inverse function into integer. And for that we have a formula called int formula. I will take this entire gamma formula inside the int formula so that it always returns the integer in case of Q. Because why it is required? Because Q is our demand, and demand cannot be non-integer value. We are selling some integer product, that means we are not selling some rice or flour or anything like that, which can be in non-integers also. Actually we are selling some countable products, so that is why we are assuming that demand is integer. And so now the fixed cost is following normal distribution. So what is the formula? You see here, norm inverse formula. So norm inverse, probability is again random number, rand. What is the mean? Mean is 15,000 and standard deviation is 2,500, right? So this is your fixed cost. And what is the TP value? TP value is simply S minus V into Q minus, this will be into minus F. Check this formula. B2 is your S, C2 V, D2 is your volume, and E2 is fixed cost. So this becomes your total profit. So I will make sure that these are all in 2 decimal places. So this is important because after that you will just copy these things downwards. So whatever formatting you want to do, you should do it in the first replication itself, so that it can be copied down until the end. So now I will delete these things. I don't need this. I need these questions to be answered. So I will keep this, just make the font size little smaller. Okay, so this is our first replication. So what is the next replication? Replication number 2. So this plus 1. So this is replication number 2. What is going to be the selling price? It is same. So selling price is not changing. It is the decision variable or the controllable variable that is in your hand. So the same $300 is your selling price. And what is your V? You will just copy this. Actually you will copy all these things. So you see here, every time you just refresh the page or press F9 in your keyboard, or just save the Excel file and reopen it, or do whatever thing, copy, paste, whatever, refresh, any action you take, these numbers will change. Why? Because we have used this rand function. And when you use the rand function in every possible opportunity, Excel workbook will give a new value to the rand function between 0 to 1, and based on that the random variates also will change. That is what is happening here. And once this is done, you can just drag it down to make this a long list of replications here. So in my case I will take just 1000 replications here. Just 1000 replications here, and based on that I will try to answer these questions. But actually you can take more replications also if your computer is not too much hanged up or just running fine and not age old computer, then you can use 5000 replications or 50,000 replications. This is up to you. More replications you will use, it will take more RAM, more power or whatever from the computer, and the Excel file will tend to hang. So if your PC is updated, there should not be any problem. So anyway, I have taken 1000 replications. 1000 replications is more than enough in for academic purpose. If you are doing it for your actual workplace, then the replication number can be more. Okay. So what is the first questions to answer? Average profit. Average profit. I will write the headings here and then I will delete this text box. Then what else? Variance. Variance is asked. Then the standard deviation is also asked. Then the probability of loss, that is also asked. I have skipped one row here. Why? I will tell you. I will, before calculating the probability, I will count the number of losses. So from these counts, I will calculate the probability. So that's why I have created this additional row. So once this is done, I will just compute average. How to calculate? Just use the average formula. What is the range? Range is from F2 to F1001. But you can use this formula, no problem. But to make things simpler, you can use this F colon F. If you do this also, this will work. So what is the benefit of this type of formula? So for example, you want to increase the number of replication after some time. So maybe you want to add few more replications or make this 1000 replications are already there. You want to make it 5000 or 10,000. So every time you cannot or may not want to change the range over which the average function has been calculated. So if you write F colon F, then automatically the entire F column will be used for calculation of average. Similarly, for variance, I will use this formula variance dot S. So in most of the cases in simulation, we are dealing with sample data. So even if you are using 1000 replications or 5000 replications, this is only sample data. So therefore, always use the sample variance formula. So variance of S, again you can use FF here. You don't have to take the actual range, that is F2 to F1001. You don't need to write that. Just use F colon F to calculate the variance. Once you calculate the variance, you can either use the square root of this, square root of variance to calculate the standard deviation, or just you have the standard deviation formula also, standard deviation dot S, again S because we are trying to calculate the sample standard deviation here. So again use F colon F and you get the standard deviation. Now here when you are counting the number of losses, basically you will count the cases here where the total profit is negative. So how to count that? One should use count if formula. So what is the purpose of count if formula? Count if formula is used to count the items in a range based on a particular criteria. So what is the criteria in our case? Our criteria is less than 0. And what is the range? Range is again FF, no problem. And what is the criteria? Criteria is less than 0. But can we write this? We cannot. If you try to write this, something will happen. So there is a particular syntax. You must remember this. You first write the less than function within the quote unquote, and then put and then 0, right? So this is the syntax you should remember. Now COUNTIF function can be used in many ways. The most simplest form is, suppose you just want to count the number of rows with a particular value. So for example, you want to see if exactly a particular value is appearing. So for example, 0 is appearing, then there is no need to write like this way. This is not required. You just write 0 and it will calculate. But if you use less than sign, or greater than, or less than equal to, or greater than equal to, then you cannot write in this way. So in that case you have to use this particular syntax, this and 0. So this will give you the number of cases out of this 1000 for which losses has occurred. That means what? Negative profit. So it has counted only the negative profit rows from this 1000 rows. So 338 such negative profits have been observed in this data, which will change obviously if you refresh the page many a times. So then what is the probability? Probability is simply this divided by 1000, because we have taken 1000 replications and out of which 333 was found having negative profit. So the probability of loss is this 0.319. So again, if you refresh this quite a few times, this value will change, but you can see that it is changing not much. And believe me, if you use the number of replications more than 5000 or say 10,000, then this will tend to freeze. So you can try that here in your own exercise at home. Just use the number of replications close to 10,000 and see the changes in probability after refreshing. So how am I refreshing? I am using the F9 key of the keyboard. So press F9 to refresh this. Of course, we are in an elementary stage of developing the simulation model, and therefore we are using this F9 business, and there is no need. We can actually populate these probability values using data table or other options. But just to understand the process, you can press F9 to see how this probability and other values also, average also, variance also, are changing. So you can see it is pretty much around 0.3, and this variation can also be minimized if you use more number of replications. So that's it. That's how an elementary simulation model can be built using Excel spreadsheet. And now in the next video we will see how we can develop the same model using data table option. So if you go here, data, what if analysis, there is something called data table here. So if you use the data table option, then the first replication, it will be a model here, and all other replications will be made instantly by the data table only. So that is another way of creating simulation model that we will learn in the next video. And also You see here, we had our decision variable, this one, 300 was the decision variables. Now you can ask simple questions like what could be the best decision variables in order to have the maximum average profit. But that will be a stupid question, because in this case the demand is actually independent of selling price. So if you increase the selling price, the average profit will tend to increase. There is no doubt about that. So you make it 400, it will increase. You make it 500, so it will increase. So there is no limit to that. So this question is pointless, that how much your selling price should be in order to have maximum average profit or anything like that. So in the next video we'll try to complicate this model little bit, just to add some spices or meat to the basic problem, where we'll try to write the demand equation in terms of the selling price. So when you increase the selling price, the demand will tend to reduce. That is the closest thing we can think about the real life situation. So the demand is always a function of selling price, it is nothing independent. So if you increase the selling price, demand will tend to decrease. So that way we'll define our demand function, and within that demand function some parameters will be there which will be expressed in terms of probabilistic variables. So don't worry about that, we will study those things in the next video. First try to understand the model build-up procedure that we discussed in this video, and again practice this at home so that you can independently develop this model. Consciously I am not posting the Excel sheet in the description box, because otherwise people will just copy that and will not practice. After the series is over, after few days, let us say 1 month or so, I will post all these Excel sheets in the description section. But before that you should practice and be comfortable with the basic models, so that when we develop more complex models, things will be easier to you. So that's it, this is the end of today's video, and please wait until the next video is uploaded and practice this at home. Thanks for watching.